Alright, welcome. This is Mr. Trink, and I'd like to show you how to solve systems of equations by substitution. And it's one of two methods that we're going to look at in the grade 10 course, specifically the MPM 2D course. We're going to look at substitution as well as elimination, and that's going to be covered in a separate video. We're going to do two examples today for substitution, one which is I would call a simple substitution question, and one that is a little more difficult. So let's take a look at our first challenge here, and that is this question. I would categorize this as simple substitution because we already have a variable that's been solved for. Normally in a substitution type question, we're going to isolate for one of the variables, get a variable on one side all by itself with a coefficient of 1. In this case, it's already done for us. In fact, it's already done for us in both of the equations here. So the first step is going to be very easy. That is to isolate for one of the variables, already done. So we can jump right to the substitution step, which is going to allow us to, in this question, sub y equals 2x plus 25 into what I am going to refer to as equation 2. And it's important as you go through these questions that you try to explain your steps as much as you can. So don't just go right into the calculations. Label your equations, explain what you're substituting into where, and explain your thinking. Then even if you make a mistake, you're going to be able to get a fair amount of marks for that. So what I'm going to do is I'm going to replace where I see y in equation 2 with 2x plus 25. So what I'm going to get is on the left hand side, replacing the y with 2x plus 25, and that is going to equal x minus 4. Now I'm substituting into brackets just to get you into that good habit. In this case, they don't actually add anything, so we can drop them right away. If, however, we were substituting into a variable that had a coefficient, having the brackets there will remind us that we need to distribute that coefficient to every term inside the brackets. So I'm just going to drop those brackets. So I'm just going to rewrite the previous line, and I can go ahead and start collecting like terms. I'm going to bring all of the x's to the left hand side and all of the constants to the right hand side. You can think of it as subtracting x from each side of the equation and subtracting 25 from each side of the equation, whatever works for you. So I'm going to get 2x minus x on the left hand side and negative 4 minus 25 on the right hand side. This is going to give me x is equal to negative 29. Now that I have a solution for x, I can substitute that into either of my two original equations to get the value for y. In this case, it's easier to substitute into equation 2, I would say. It's just a simpler equation. So I am now going to sub x equals negative 29 into equation 2, and I'm going to get y equals negative 29 minus 4, and you'll notice that I substituted the x as into parentheses once again to make sure that if there was a coefficient there, I would multiply that in. So it's going to give me y equals negative 33. And I can then finish off this question by saying, therefore, the solution is negative 29, comma, negative 33. So we want to give the ordered pair solution to the equation. and make sure that we include the parentheses and any signs and separate the x and y by a comma, remembering that x comes first. Alright, so that's the first kind of question that we can get. That's a simple substitution question. Let's do one that is a little bit more difficult. This one is going to require that we actually solve for one of the variables first. So we're starting off from this point. I'm going to go ahead and label these two equations 1 and 2. That's going to help me identify them as I go through my solution and explain my steps. So what we need to do first is solve for either x or y in either equation 1 or equation 2. How do you know which one to start with? What you want to do is look for a variable that has a coefficient of either positive 1 or negative 1. Those are going to not require you to divide after you isolate for that variable, which is going to mean that you're not going to deal with fractions. So we definitely want to try to avoid unnecessary complications in these solutions. So if we can pick a variable that's going to give us a simpler expression to substitute into the other equation, that's what we're going to go with. So in this case, we're going to look at equation 1. Both of the x and y variables have coefficient of negative 1. So we can isolate for either x or y easily by bringing the x or y over to the right hand side. So what I'm going to do is say from 1 x is equal to 7 minus y, and take a moment to think about that. All I've done is brought the x over to the right hand side and then rearranged the minus y plus 7. I just find it easier to deal with the minus as a binary operator rather than leading off with a negative y. I think that this is less likely for me to make a mistake. So anyway, we can now sub x equals 7 minus y into, this is important, we're going to substitute into the other equation. We cannot substitute it back into the equation 1 because that's the one that we were working from. I'm also going to label this as equation 3 just so that we can come back to it later and easily refer to it. So I'm going to replace the x in equation 2 with this expression 7 minus y. And I'm going to substitute into parentheses to remind myself that I need to distribute that leading coefficient 2 into the entire expression for x. So I have 2 times 7 minus y minus 5y plus 21 equals 0. And I can now go about solving for y. To do that, I'm going to need to expand. So I'm going to distribute this 2 to both of the terms inside the parentheses. And so I'm going to get 14 minus 2y minus 5y plus 21 equals 0. I can now collect like terms, and I'm going to get negative 7y plus, that looks like I'm going to get 25 and 35 equals 0. I can now bring this constant term 35 to the other side, or I could bring this negative 7y to the other side. Really doesn't matter which I do. Just make sure that you are not making a mistake with the signs here. Okay, so I left the negative 7y on the left hand side. If I would have brought that over, I would have had two positive values. Really doesn't matter here. I can now go about dividing each side by negative 7, and that's going to give me y equals 5. Now that I have that, I can substitute that value into equation 3. Because that's already isolated for x, it's going to be more efficient for me to substitute into. So I'm going to say now sub y equals 5 into equation 3, and I'm going to get x equals 7 minus, and I'm going to substitute that 5 into parentheses. In this case it's not really an issue, but it's a good habit to get into. So I'm going to get x equals 7 minus 5, which is 2. I can then conclude by saying, therefore, the solution is, and I'm going to provide it as an ordered pair once again, 2, 5 in parentheses, and my solution is now complete. So that is how you solve by substitution in a more difficult kind of question. Stay tuned to the channel for another video on how to solve by elimination. Elimination, I think, is easier, a little simpler, at least in my opinion. So hopefully that'll be a good tool to have in your toolbox. Thanks for watching.